In this video, I'm going to talk about centripetal acceleration and centripetal force. So, for the sake of this description, I want you to think about an object moving in a perfectly circular path at a constant speed. I say constant speed because the velocity is constantly changing. So, for example, I can be moving from velocity 1 here to velocity 2 here. At a constant speed, my speed wouldn't change as I travel across this arc. However, because I change direction from going up to going left, I have changed my velocity. Remember, velocity is a vector, so it has direction. And so if you change direction, you change velocity. When I change direction, constantly going around the circle like that, what's happening is the object is accelerating. And I can find the acceleration by looking at my two vector arrows. So as I cross this arc from v1 to v2, my velocity goes from pointing up, v1, to pointing over to the left, v2. And so if I wanted to find my change in velocity, I could look at this direction here and find my change in velocity. And remember that a change in velocity is the same thing as acceleration. So I see that my change in velocity as I go across this arc is this points toward the center of the circle as I go from v1 to v2. If I were to repeat this process, maybe go from v2 to v3, I would see something similar. So as I go from v2, which is pointing that way, to v3, which is pointing down, I see that I have a similar change in velocity that points toward the center. And if I did this for any point all over this circle, I'd see that the change in velocity, or my acceleration, always points toward the center of the circle. And this makes a lot of sense, basically because of the name centripetal acceleration. Centripetal means center-seeking. So the acceleration is always toward the center of the circle. We can mathematically describe the amount of centripetal acceleration we're experiencing with the equation centripetal acceleration is equal to v squared over r, where v is the speed that I'm traveling around the circle, not velocity because I'm constantly changing my velocity, and r is the radius of my circle. Okay, this acceleration, like all accelerations, is caused by a force. And if you remember Newton's second law, force is equal to mass times acceleration. So if I were to take this centripetal acceleration and multiply it times my mass on both sides, I would see that my centripetal force is equal to mv squared over r. Okay, so these two equations here are really important for you to remember, and you're going to need to apply them in some questions in the future. The last thing I want to say about centripetal force is its relationship to the velocity. So the centripetal force is always pointing toward the center of the circle, and so if you look at the centripetal force, it means that it is always perpendicular to the velocity. So as the object travels around in a circle, the centripetal force will always be perpendicular to whatever the velocity is at that time. Okay, that's all I have to say.